Hello! In this video, we'll be demonstrating the creation of a file server that has both an HTTPS front-end and SFTP access. We'll run that file server on Google Kubernetes Engine, but the setup should be portable to other Kubernetes environments without too much effort. The lower portability part of the setup will be with things like static IPs and DNS management, but those tend to be relatively easy on any provider. Everything that we walk through today is available for your reuse via the GitHub repository that's linked in the description of this video. Okay, so let's very quickly create a diagram for what we're trying to achieve, and then we'll jump into the Google Cloud Console and an IDE to set up these resources. We want our engineers to have access to the file server via SFTP, but we also want broader user access via HTTP. This will give us two distinct networking paths, one for SFTP over port 22 and one for HTTPS over port 443. To keep the Docker containers clean with a single process, we'll use two containers in one Kubernetes pod, one for the web server and one for the SFTP server. Specifically, we'll use the Caddy and OpenSSH projects. We'll need to provide a configuration map as well as a persistent volume claim to enable this deployment. If you're familiar with the Caddy web server project, you'll know this configuration as our Caddy file. If you're not familiar, no worries, we'll explain in due time. We'll want a persistent volume claim to back this file server so that pod restarts don't destroy all our files. Now for those networking paths, we're going to want two services. Part of the reason for using two separate service resources instead of bundling everything into one is that our ingress resources are very useful for configuring and managing HTTP networking, but they don't support layer 4 networking. We need layer 4 networking for the SFTP path over TCP on port 22. So we'll leverage the power of these ingresses for the HTTP side of things, but use a separate service for the SSH side of things. Okay, so here's the flow of our traffic. It'll come from our users through this networking path for HTTP and this networking path for SFTP. With what we're trying to achieve now established, let's jump into a cloud IDE to set these things up. We'll assume you already have a Kubernetes cluster ready to go for the deployment of all these Kubernetes resources. We don't need anything special on that Kubernetes cluster. Just note that we're using the GCE ingress class that automatically comes with GKE clusters in this demonstration. If you have a different Kubernetes environment, you'll need to modify these resources a bit and possibly set up an ingress controller yourself. Again, all of these YAML resources are shared in the description of this video. We're hosting that code on GitHub for your reuse and inspection. Okay, so let's dive in and build out some of our assets here. Let's first build out our file server. We need our deployment, configuration, and storage volume configurations, which I'll paste in here from the GitHub repository. There's really just one thing we need to change here, the SSH key. We'll need this for the SFTP authentication. We'll set up that key in just a moment. I also want to highlight that we're going to be running off a nodomatic.io domain and a nodomatic username, but feel free to modify these. You may even want to add resource specifications and other additional configuration to these resources, as they are just a simple starting point. In any case, let's move along and create our key. So I'm going to copy in a generic command here for creating an SSH key. We're going to use this ED25519 algorithm as a secure way to generate that key. Make sure that the username in your key creation matches the username in your deployment environment variable. In my case, there's already a key in the default save location, but I know it's okay to overwrite it. Now we simply need to get the public side of the key pair and use it for that environment variable. Great, so these resources all look good. Before applying, we'll just want to set up our networking with a networking.yaml file. Again, this code is available on GitHub for your reuse. There are just a couple of things to walk through with this configuration file. First off, make sure to change this domain for the managed certificate. We'll be using a Google managed SSL certificate to make our life easy, and you'll need to tune this to your own use case if you're using something different. We're specifying the GCE ingress class, which is automatically available in the default on Google Kubernetes Engine. We're providing a static IP name, and we'll need to create that IP in the console momentarily. We're also providing a front-end configuration, which is down here, and then pointing the ingress to the managed certificate. For the back end of this ingress, we'll use the file server HTTP service on port 80. So we'll be terminating the HTTPS encryption at the load balancer level. In our front-end configuration, we're just redirecting HTTP to HTTPS for a more secure setup. At the bottom of this file, we just have a couple services, one for HTTP, which can be a cluster IP because it's behind the ingress, and one for SFTP, which needs to be a load balancer type because it needs to be exposed without using an ingress. Enough with the explanation, let's get things running. In the terminal, we'll check for our available clusters. Looks like we'll need to use a set project command and probably also authenticate. And now we can see our cluster. Let's prepare the IP for our cluster installation. In the console, we'll search for IPs. And we need to reserve a global external static IP. I've done this in advance to expedite the demo, but it's a pretty simple creation form here. Just make sure to choose global and IPv4. Once you've created it, grab the name of that IP and make sure that it's used in your ingress. And we should be able to apply these resources now. After we apply them, we'll need to set up a couple DNS records, but that'll be a quick last step before being able to test the application. So let's get kubectl authentication working for our cluster and test that with the get namespaces command. Then we'll apply our resources, and again, I've done this step in advance to expedite the demo. Your resources will take a bit longer to provision the first time compared to the reapply that I just ran. Once you wait a little bit, you'll start to see IPs for your SFTP and HTTPS endpoints. Ultimately, one IP will come from the manually provisioned static IP from earlier, and the other one will be automatically created by your load balancer service. To set up the DNS, I'm going to switch over to a different project where we have our DNS set up. Here you can see that we've set up fileserver.notomatic.io to be that static IP from earlier. Then we're using sftp.notomatic.io for the load balancer service IP. Not only are these DNS records required for resolving the domains, they are also required for Google Managed SSL certificate provisioning. Google can't run the HTTP ACME challenges if the domains aren't pointed to Google's load balancers. With our proper setup, though, I can run a kubectl command to see that managed certificate. And note that the provisioning is complete. Again, your initial installation will take a bit longer since I've set up some of these things in advance. We can further validate our setup by running a dig command for sftp.notomatic.io, where we'll see the same IP as our load balancer service. If we run a dig command for fileserver.notomatic.io, we're going to see the manually provisioned static IP, which is being used for our ingress. With the network looking good, let's test the file server. So first, let's access this through the browser. If we go to fileserver.notomatic.io, we'll get redirected to HTTPS and have a nice file navigator interface. Now, there's actually no files yet, so we need to push some. Going back to our architecture, we've set up a public file server so that users can download files from the HTTP front end, but they can't upload or change anything. If they have a valid SSH key, however, they can use SFTP to run, read, and write operations. We'll use that second read-write access approach to upload a file. We'll run an SFTP command, specify a username, and accept the fingerprint. We may not be in the var www HTML directory, so we'll switch to that. From here, we can upload our test.txt file. Now, if we jump over to the console, we'll see the empty test.txt file here. Let's exit, update the file to include some hello world text, and then re-upload it. And it looks like we're, again, in the wrong directory, so let's try that again. Okay, so we have an updated file with a new last modified time, and we can see the new text contents here. All right, so with this architecture, you'll be able to set up a file server that has not only a nice front end for downloading files, but also an SFTP networking path for running uploads or downloads. Let's quickly touch on costs for an architecture like this. So almost all of these services are running on Kubernetes, with just a couple things reaching out to other Google Cloud services. So we'll throw a bucket around all these Kubernetes resources. We won't pay for these directly, but rather we'll be paying for the Kubernetes cluster that they run on. For more or less default setup, we'll be charged about $101 per month. The most notable external service costs will be with cloud load balancing, which is used indirectly via our ingress resources. For that load balancing, we'll be at about $18 per month. The static IP is going to run us an additional $3 per month. So in the end, we're running at about $122 per month. The cost is pay as you go, so a few hours of runtime, like we had for this demo, will be a small fraction of the monthly cost. You could probably bring the cost down to about $50 or $60 per month without significantly changing the architecture, but less than that will be challenging. Heavy traffic sites may also bump up the costs due to increased compute needs and increased networking costs. With the costs now understood, let's go ahead and tear down our demo resources. We'll run a kubectl delete on the networking.yaml. Since this is going to destroy the ingress, we'll have automatic deprovisioning of the related cloud load balancer. That executed successfully, so we'll delete the file server resources. Then we can go ahead and delete our DNS records, IP, and Google Kubernetes Engine cluster. Remember that we have our DNS in a different project, so I just need to switch to our original project here. We'll delete this IP here, and then switch over to our Kubernetes Engine cluster to finish the cleanup. All right, so we hope this architecture is interesting and useful. If you have any questions on this setup or challenges, feel free to post those in the comments of this video and we'll respond as soon as we're able. Again, I'll remind folks about the GitHub repository link in the description of this video. Feel free to copy, paste, or fork that code as a starting point. Thank you for watching.